We're on 12.1 and 12.2. So module 12 is all about quadratics and graphing them. So we have done factoring, and hopefully you guys did your test. This one is just all about graphing. So this is going to be a little bit harder to do without having worksheets and things like that. Hopefully you guys have a printer. If not, just be very organized when you are showing all of your work, especially your notes. So 12.1 and 12.2, because they're so closely related, I'm going to do only notes today. So Wednesday's assignment is just doing the notes and uploading all of your, documentation that you did them into Canvas. And then Friday is the actual assignment and an exit slip. So 12.1 is just the intro. So we're going to identify key characteristics, and we're going to do a little bit of solving for the first part. At 15 minutes, the video will cut me off, so I will pause it, and then I will start a second video that you will need to watch at the end. All right, so Intro to Quadratics, Part 1. Here are some definitions that we need to go over before we can do anything, because this is all new terminology. The standard form of a quadratic equation is this right here. So y equals ax squared plus bx plus c. Now that should look somewhat familiar because we just got done factoring, and you guys all factored trinomials. When we graph something like that, so when we graph a quadratic equation, it's going to be making a U shape, and we call that a parabola. So I'm going to be using parabola a lot, that term, when we are working through this next module. So parabolas are used. So we've graphed lines, and we've done exponential graphs, and we'll have a lesson on Monday of next week comparing all three things that we've learned how to graph this year. But for right now, we're going to focus on the parabola. So we don't have graphing calculators, but I can show you a rough sketch. So when we have something like y equals x squared plus 2x plus 5, I know that's going to open up, and it's going to be a normal U. I know that because when I look at this first letter, so that x squared, it's positive in the front. So this first bullet here says if a is positive, then it's going to open up. Okay. On the flip side, if a is negative, so we have a negative x squared. So if a is negative, it's going to open down. So I could just do a rough sketch and have my U opening upside down. So you're looking at the front number to see, is it going to open up or is it going to open down? Okay, so that's the two ways it can be flipped. So you have positive or negatives. Okay, then we have something called the axis of symmetry, and that is when you look at a parabola or do the math, you'll be able to find an equation that would cut a parabola completely in half. The formula to find axis of symmetry is right here, and we're going to use this throughout all of the notes. So x equals negative b over 2a. We find the axis of symmetry because then that also leads us to find something called the vertex. The vertex is the turning point of a parabola, and within a vertex, we have a lowest point, which is called the minimum. And then we have the highest point, which I hope you guys can guess, is then called the maximum. The last thing that we need to talk about, and I added in here, is zeros. Typically, we have a completely separate lesson where we go over zeros, but we had to eliminate that because of e-learning. So we're just going to briefly touch on it here. A zero is where the x value makes a quadratic function equal to 0. And in this case, for graphing, which is what we're going to be doing, it is where the graph crosses the x-axis. And I'm just going to introduce it like I said. This was supposed to be a completely separate day, but we're just going to try to touch on it, and then you guys can do it next year. Okay, so there's our definitions that we need in order to even start today. So you need to have all this written down for your notes when you upload them. Examples. So let's actually just start looking at a graph and identifying all these things before we do math. All right. So It says identify the axis of symmetry, the vertex, the max and min, the y-intercept, and the zeros if there are any. So I'm going to abbreviate this because I don't have a lot of room and I'm terrible at writing on this iPad. Okay, so the axis of symmetry, I'm going to call that my A of S. So that's where it cuts your parabola or your U-shape in half. So if I am looking at my red U right here, it's symmetrical, right? So that means it can be cut in half. So if I cut it in half, I'd be cutting it in half right here. I cut it in half at 2, so it's x equals 2 is my axis of symmetry. Your vertex is the turning point. So right here is my turning point because my parabola is going down and then it stops and then at some point it starts turning the other way, hence the reason why it's called a turning point. So the vertex in this case is at that point, which is 2, -1. So we're just looking for that ordered pair. This parabola opens up. So this is the lowest point on the whole thing. So my vertex is a minimum. The y-intercept is where does it cross this y right here. And it crosses the y. If I keep tracing my parabola, it crosses the y right here at 3. So my y-intercept is at 0, 3. Again, ordered pair. And then the last thing is the zeros. We're just going to say something very short about this and then move on. So the zeros is where it crosses now your x-axis. So your y-intercept, where does it cross the y? Your zeros, where does it cross the x? And it's crossing right here at 1 and right here at 3. So my zeros would be x equals 1, x equals 3. Okay, so those are all the key points. 2, same thing, and now I'm going to go a little faster so I can have time to show some actual examples that we need to do. So your axis of symmetry is where does it cut it in half? So looking at my parabola, to cut it in half, it's going to go down the middle. That x value is at 1, so it's x equals 1. Your vertex, again, is your turning point. So my graph is heading down, and then I'm going to trace it up, trace it up, trace it up. It hits this spot right here, and then it turns to go back down. So my vertex is 1, -1. Maximum or minimum, this is at the very top of the parabola, so this is a max point. The y-intercept, where is it crossing this line right here? And it's crossing at -2. So my y-intercept is 0, -2. And last but not least, the zeros. So where does the upside down U touch this x-axis right here? It doesn't. It never goes above this. So there is none. Or there are none, I should say. So there aren't any zeros. Okay, so that's identifying all those definitions by looking at a graph. Let's say you don't have a graph. Like this. So I have my quadratic. I have all these things I need to figure out, but I don't have a graph. So we're going to go back to axis of symmetry, which is, I should have written it somewhere on this slide. Axis of symmetry, the formula is x equals -b divided by 2a. So I'm going to be going through all of that. Okay, first thing I'm going to do, and I didn't give myself much room, let's go through A, B, C, all right? This is your A, this is your B, that's your C. So my A is 1, my B is 8, and your C value is 15. Now I'm going to use that information when I go through with my axis of symmetry. So that's always your starting point. So I'm going to start with x equals, it says -b, so I'm going to write my negative sign. my b is 8, all over the 2, which is always there, times my a value of 1. 2 times 1 we know is still 2. Divide these out and I'll get negative 4. So my axis of symmetry is x equals negative 4. To find the vertex, you're going to take negative 4, so this answer, and if x is negative 4, that means I'm going to plug it into both of these x's and I'm going to solve it. So to find my vertex, I'm going to take my function and do negative 4 squared plus 8 times negative 4 plus 15. So negative 4 squared is 16, 8, and negative 4 is negative 32, plus 15. Put that in your calculator, and you will get 1. Negative 1. Sorry, negative 1. Okay, so then your vertex is the negative 4 that you already had, and y is negative 1. Max or min, okay, my a value is a positive 1. So if my a is positive, that means that my u is going to open up. So this is a minimum point. And then your y-intercept is always whatever your c is. So if my c is 15, my y-intercept is 0, 15. This is a lot, I know. Here we go. Next, okay, axis of symmetry, vertex, max, min, y-intercept. All right, axis of symmetry. Again, we have to do x equals negative b over 2a. Let's figure out what my a, my b, and my c are. A is 3 now. Oh my gosh. B is negative 12. And c is 5. Alright, so my formula is a negative b. Keep that in mind. But then my b is a negative 12. So I'm going to have double negatives, which you know will turn positive in a second. The 2 is always there, and my a is 3. That's going to be a positive 12 over 6, which is 2. So my axis of symmetry is x equals 2. Then I'm on the vertex. So then I take my 2 and I plug it in for the x's in the equation. So 3 times 2 squared minus 12 times 2 plus 5. So that's 3 times 4 because you got to follow order of operations. 24 plus 5. Multiply to get 12 minus 24 plus 5. So y is negative 7. So your vertex is 2, negative 7. I have to stop here because I'm going to run out of time. It's going to cut me off and start a new video to finish.